you have a great day. So yeah, apologize for my voice. Sorry, I haven't completely recovered from the cold. So today, I hope I could speak 2 hours. So let's see. So could you type something in chat just regarding audio and video? Is the audio is fine? Video is fine? Can you see the presentation? Could you just type or just say?
Yes, the video and audio is clear. Thank you.
Thank you. Okay. Okay, so today's presentation is titled Root Cause Analysis. As well, before we actually start, could you also type or say, have you done root cause analysis before? Or have you heard about root cause analysis? Or at least have you heard what root cause analysis means, even if you don't know what it means, you don't know techniques. So could you say something or could you type? So I just would like to understand what kind of level of root cause analysis you have at the moment.
Yes, I heard. I heard and I have used the root cause analysis, and which helps us in knowing exactly the issue underlying the bug. If you want to analyze the more detail of the bug.
Okay, thank you. Yeah, and I'm just reading a chart. So actually, you've done it before, you heard and you've done it. That's amazing. So that's cool. So it means you at least you work, your organization does it, or you just did it because you wanted to try it. Okay, that's amazing. So let's see if something new you could, yeah, you could know today. That's brilliant. Okay, thank you guys. So let's get started. Okay, so let me introduce myself. So my name is Yulia, and I'm a lead software tester at a small risk intelligence company, Polcat, based in Bristol, United Kingdom. So I have more than 7 years experience in software testing. So basically, I started as automation tester, then I moved to more general testing, and I've done basically all kind of testing. Also, I've got PhD in mathematics, and recently I got ICTQB full advanced certificate. So if you have any questions, or if you would like to talk more about root cause analysis, or if you just want to connect, please do reach me out on LinkedIn. So at the bottom, you can see the link. So, but it should be easier to find me just on LinkedIn. So not to be confused with the name, because you see LinkedIn with I and with you, so you should be able to find me. So please do connect. Okay, so what's the agenda for today? So probably it should take no more than 30 minutes, just the theoretical part. So we will be talking about the definitions, the origin, when to conduct, when to not conduct root cause analysis, who should do it, what's the process in general, regardless the technique you use. And then we will go through the techniques. So we will start with the simplest ones, 5 whys, Pareto principle, and then we will go to more complicated, complex techniques, Ishikawa diagrams, FME, and fault tree analysis. And we will finish just with some examples of root cause classification in software testing. So it shouldn't take more than 2 hours, but let's see how it's going. And we might have a break at some point. Okay, so if you don't have any questions regarding the agenda, I think we could start. Okay, good. Okay, so what is root cause analysis? I'm pretty sure you can find lots of definitions. So the simplest one is just that root cause analysis is a class of problem-solving methods aimed at identifying the root causes of a problem or event. I would like to emphasize that we're talking not only about problems or defects in software testing, we're talking about the problems and events in general. So this technique, this set of techniques, class of methods, you could apply to different industries, to different problems. So basically, when you counter any issue, any question, which you would like to understand more, you would like to dig more to understand what's underneath, you could use one of the techniques. Yeah, you could try something simpler or something complex, depending on the tasks. But I just would like to emphasize that it's definitely not only about defects. So the second definition is just about defects, and it's from Rex Black. So in terms of testing, so root cause analysis is the analysis technique that determines underlying mistake which led to introduction of a defect. So, and the very important thing that by directing corrective measures at root causes, this hope the likelihood of defects recurrence will be minimized. And that's probably the main goal of root cause analysis. It's to minimize this defect recurrence. So you can see 4 kind of main goals of root cause analysis. There is another definition, which is more probably comprehensive definition, but it's a long definition. And it just says that you could apply it to different areas, to different kind of problems. And the part of root cause analysis is as well agreeing corrective actions and trying to mitigate or eliminate the causes. That's a very important thing. It's not only to find root cause, but trying to mitigate or eliminate it. So what was the 4 main goals? So we just said that's about defect recurrence, to minimize defect recurrence. That's probably the main one as well. So we should understand that we do root cause analysis not just of idle curiosity, or just blaming people, just saying, oh, you did this bug or something like this. No. So it gives you opportunity to find patterns and then to work on the process improvements. So rather than blaming people, blame the processes. So everybody makes mistakes. I certainly do. And if you blame people, just showing them what they did incorrectly, I don't think they will next time prevent this mistake of happening. So the more important thing, it's understand why it's happening. So what is it about the way we work that allows this mistake to happen? How can we change the way we work so it's harder for something to go wrong? So most of the time, it has to do with skills, knowledge, or the way the work is done, with the process, not the person itself. So it means that something could be wrong in your process, in your organization. So if we're talking about the process improvement, so sorry. Yep. So I can give you one example. So for instance, your management could ask you, could say, could you reduce the number of defects, in 25% next year? Okay, it sounds interesting, right? So how would you do it? 25%. But let's say before you've done a root cause analysis, and you know that 50% of mistakes, they relate to branch or loop conditions, some memory management, or just lack of comments in the code. In this case, by training programmers in this area, the number of code mistakes can easily be reduced by 25% within the year. And the root cause analysis, it's a part of process improvement techniques methodology. So usually, I mean, as I said, you could apply it to any kind of problems, any kind of events, issues you have, but probably you would most benefit from it when it's a part of this whole process improvement. Okay. So why is root cause analysis important? Okay, we just mentioned it. So it's getting to the root cause means stopping it from the happening again. That's a very important thing. It's a structured approach, and it provides a permanent solution. It's not just fixing some symptoms, it's just finding the solution, just understanding why it's happening, what the solution is, and then fixing the root, not the symptom itself. So also, it may be just a part of policy or goals of organization. Especially, it very much depends on an industry or just organization, what kind of levels this organization. But very often, especially, healthcare and machinery engineering is just a part of a policy to do root cause analysis. It's providing long-term improvements, yes. It's a powerful vehicle for training people. We just mentioned an example that you could train people in these areas. And it's basically just a mindset. So if you do a root cause analysis just on a daily basis, it just probably becomes a habit. And it's much easier than to tackle some complex issues when you know how to approach small things. And also it's easier to sell to people from different departments when you just start with something small, just to introduce this root cause analysis with something simple, and then you try to do something more complex. Okay, so when actually did it start? So root cause analysis has existed as an investigation tool for centuries, but it was never formalized for a long time. So formally, it was introduced to the world in 1950s by Sakichi Toyoda, who's the founder of Toyota. So he introduced the technique of 5 whys, which is at the moment it's very widely used to Toyota manufacturing. So the next step, it was in 1975. So it was Federation. So this is the Federal Aviation Administration. So they established this aviation safety reporting system, and the root cause analysis was part of it. So the big actually step, it was introducing of Six Sigma by Motorola, and then later on, all different organizations, industries also started using it in 1986. And in the end of 1999, the healthcare system took a special interest in root cause analysis technique to address the high number of strange results or adverse results reported in patient safety and hospitalization standards. So basically, reports found that as a death rate due to medical errors was estimated to be more than the death rate of breast cancer, motor vehicle accidents, and AIDS. And actually, the death rate in the United States due to medical errors is just, I think it was at that time the 8th leading cause in America. So, so when they realized it, when they got this report, when they realized it, they started changing something in their system. And 1999, the root cause analysis it became an important part of their process in general. Nowadays, yeah, they do it a lot. And basically, root cause analysis can be traced just to total quality management system. And nowadays we use root cause analysis in software testing, software development, project management a lot. So basically everywhere. I just added that root cause analysis applied different industries. We just mentioned it started with manufacturing, with engineering, information technology, healthcare, pharmaceutical, change management, and of course, risk and safety management. And it's not just comprehensive list. So root cause analysis is just a part of more general problem solving process. So as I just said, it could be done for every problem you want, for when you just need structural investigation of an incident. So it's basically the good way to start using root cause analysis. Okay. So when to conduct root cause analysis? Okay, so we said that it should take place when an incident or breakdown in service occurs, particularly when it's breakdown that could lead to undesired outcomes for clients. Yes, as I mentioned a few times, you could do it for any event, but you should be aware there are some limitations. Sorry, again. It's just went. Yeah, sorry. So before you start implementation of root cause analysis, you need to consider more things. So the first thing is how often it happens. If it happens once, twice, 3, 4, 5 times, yeah, that's probably a good candidate for investigation. How critical is the failure? So if it could lead, let's say, to someone's death or to crash of aircraft, absolutely, it's a critical. But criticality, it depends on organization and industry, of course, and failure impact. If this issue, if this problem stops you of doing your work, or it could have some legal or contractual impact, yeah, absolutely, that's a good candidate. But also you should be aware Again, sorry. Just one. So you should be aware of some limitations. So when you've done it in a formal way, it could be very time consuming, resource consuming. So you should think about do run it or not. And also it could add the overhead to the process. So before you start implementing it, you need to consider all the things. Even if you want to start implement it on a very informal way, it still makes sense to consider. And yeah, and this when you have all these questions, you can also justify which kind of formality you want to do. So which kind of formal techniques you would like to use. And quite often it's based on these questions. It could be as well that in your organization they already have some processes. So yeah, basically it's probably easier in this case, just to follow what you already have. So who should do root cause analysis? So there are lots of tools and some simple techniques which could be done by one person, but it's better to do in a group during brainstorming sessions or some workshops, because in this case, you can get different opinions on what's happened and different causes. You can try to find different causes as well. So if you have a working group, it shouldn't be a big group, it should be a big team. So you can start just with a small team. So it should be people who involved in the problem within the organization. Also, a line manager could join, some internal customer if need, depends on organizational problem, and the quality improvement expert. Quite often, organizations, they invite someone external to help them to do general improvement process, improvement some methodology implementing, and root cause analysis as well, just to train them people, just to introduce it to the organization. The root cause analysis, if it's done in a formal way, so it could take up to even 2 months. When the team meets weekly, and the meetings take quite short, no more than 2 hours, ideally 1 hour. But it's not like every week you just discuss the same problems, the same issue. No. So the first week it could be just like brainstorming session. The next week you just start implementing some techniques. Then you start looking at root causes, something like this. So and it could take up to 2 months. So one person should be facilitator, and when the solution is done, when you come up with some correction measures, again, it could take from 1 day to several months. Yeah, that's another way of looking at root cause analysis. It could be done, but it's more in software development. So if you find a defect, this defect is reported by test analyst, and the test analyst tries to make an educated guess where it could be, in which area it could be, and basically what's the cause. Then developer, if it's a problem in the code, the developer does the root cause analysis during the fixing, or it could be designer if the defect in design, or business analyst, or just product owner. So it depends on the area which it introduced. But as far as you can see from this diagram that if the test analyst did the wrong guess, it would probably take more time to understand, to pin where's the issue. And once it's fixed, once the root cause is set up, it should be verified by test analysis as well. So from my experience, I did it like this. So I was a tester, and I had lots of defects, my bug tracking system, and then I trying to do this educated guess, and it worked at some extent. But you still need to have this kind of triage meetings or workshop, because in this case, it will be much faster. Because when you have this process, it could take you, I don't know, days to get to the right people, to understand where the problem is. So it's better to have this kind of working group, just to try to see where the problem, and then even if you don't want to involve everyone and spend days, weeks, months, you can just give it to the person who will be fixing. So if we're talking about the root cause analysis in general, the process, so it could be applied to any technique. So we start with a problem statement. So it's very important to clearly describe the problem and symptoms experienced. Because if it's written in a vague manner, or if it's just ambiguous or whatever, it would be very difficult and probably wasting just of time just doing this root cause analysis. So it's very important to clearly state the problem. Then it's data gathering. So data gathering or data collection, it could be just, so which symptoms, who was involved, just basically try to get all information you can. So if it's just a defect, yeah, so which environment, I don't know, which version, when it happened, which part of the product, when, everything you can get any data basically. Then it's data analysis. So you're identifying possible causal factors. It's not root causes, it's just factors. So what sequence of events leads to a problem? So what conditions allow the problem to occur? And at this stage, you can try to, you can start using actually techniques. But it's more high level, so you're just defining these factors. You're not defining solutions or root causes. The next step is root cause identification. So you use one of the techniques, and then you can try to find not only one root cause, but different number of root causes. Then corrective actions. So the corrective actions or root cause resolution. So it could be recommendations, it could be some mitigations or just fixing it. And the last stage, it's follow-up investigation. So if it happens that we fix the problem, we thought we fixed the problem, and then it happens again, it means it wasn't root cause. So it means we found something else and we just need to rethink and start again. Probably try a different technique or involve different people, but something was done incorrectly, something went wrong. That's the same process, it's just taken from a handbook on root cause analysis. It's basically the same, but there could be more stages like finding patterns, just analyzing data with some other characteristics, but basically the process is the same, the 6 stages which I just mentioned. Yeah, and recommendations. When finally you thought or you found root cause, you need to think about correction measures, about recommendations. So again, like a problem, recommendations, they should be stated clearly. So they should directly address the root cause identified during the investigation. Because if it's just something general, it doesn't basically, what did you do? So why do we need this recommendation? There is an example. So improve alignment between policies and procedures. It's too vague. It's too vague, and it means that probably you didn't find the specific cause. You might have found just kind of general root, but not the specific cause. So it should be clearly stated. And as well, so management needs to understand, needs to know exactly why failure occurred before actions can be taken. And again, the cause should be not just very general. It should be something which is very specific. And I would like to add to these recommendations, and it's probably very important. It's a very important thing. Why? So how can we understand that we found the right root cause? It would depend on the method, but like a general recommendation, if you find something which you thought that it could be a root cause, but you can't fix it, you can't do any recommendations, you can't provide any solutions, it means you can't fix it within your organization, within your team. So it means that's wrong root cause. So the root cause analysis, the root cause analysis should provide you the cause which you could fix within your organization, within your resources. But you can say, you can find something like, we don't have much resources, our company doesn't have money to implement this feature. And what to do with this recommendation, what to do with this cause. So it should be something which is very clearly stated, very specific, and you can implement your corrections. That's a very important point. Well, so it actually took less than 30 minutes to finish this theoretical part. And the next part, which will be probably, it will take us, I would say, around an hour or so, it's techniques. So today, so you can imagine, so there are lots of techniques in root cause analysis. So basically, multiple tools also available to conduct root cause analysis. So each of them has its advantages and disadvantages. And certain methods are more suitable for different industries and types of problems. So before you implement root cause analysis, you need to understand which benefits, advantages, disadvantages the technique has. So today we will be talking about five techniques, but each company in this management could have different techniques, different protocols. So let's say if you come and say, I want to use this technique, so you might already have something. And again, I would like to highlight again, to say again, that it very much depends on your organization and industry, which technique you would use. Because some of them very simple, right, like 5 whys or Pareto analysis, or more complex like fishbone or failure mode analysis or fault tree analysis. So it very much depends on your organization and on the problem as well. So in some industries like aviation or healthcare, fault tree analysis, fishbone diagrams, that's must have. They don't use usually 5 whys or Pareto charts. But if it's a small company and you want to do something quick, you can start with simple techniques. So today we'll be talking about 5 whys Pareto charts, which is simple techniques, fishbone diagram, failure mode and effect analysis, fault tree analysis. We will not talking about the Bayesian inference and change analysis. They're more complicated, and you need to understand how to conduct them. It takes more time to understand how to conduct them, but I'm pretty sure you can find lots of information on them. Also, I would like to mention that I'm not going to show you some specific tools. You can find lots of different tools on the internet. So just basically Google how to conduct Pareto analysis, how to do fishbone diagrams analysis or fault tree analysis. There are plenty of free tools, or you can find something which is more comprehensive. So just basically Google and that's it. You can do just on a sheet of paper, but it's better to use one of the tools. But for some simple things, you could just do it like in 2 minutes. Right. So let's start with 5 whys. So I mentioned earlier that 5 whys was introduced by Sakichi Toyoda at Toyota factories. So it's very simple technique. Basically, it's simple, but it's yet effective to determine any kind of root causes. Just asking why. As a rule of thumb, 5 times should be more than enough to find the cause for most of the problems. But okay, it's just a rule of thumb, so it could take you 3 whys or it could take you 15 whys. But usually 5 whys should be enough. So when to use 5 whys? So the 5 whys most effective when used to resolve simple or moderate difficulty problems. Yeah, because it's very simple and it has its drawbacks. So it's better to use it for simple problems. Not in problems, just problems and events. So it might be not suitable for critical or complex problems, particularly because you're trying to find one root cause or just limited number of root causes. But in fact, there could exist multiple causes. So it could be used before and part of the more in-depth approaches. So it's just so you can try it out before you actually try to do something else, or it could be just a part, like a first step of your root cause analysis with more complex technique. And as well, it could be used in retrospectives. that's interesting point. I don't know if anyone of you just use it in retrospectives, but it's a very useful tool. So basically, when you ask what went wrong, what went good, which improvements we should do, you could just use root cause analysis, simple 5 whys. Just ask why it went bad or good, and to find this cause. Because quite often we spend not enough time just to finding this cause. We're trying to implement some solutions, but not really for causes. So if you spend a few more minutes, you can just use sticky notes or anything you use in your Reddit meeting. Just get this simple root cause analysis. It would definitely benefit your team. It would be much easier to find these recommendations, these correction measures. And if you implement it, if you do it just every retro meeting, it just takes a few minutes, but it could be very successful thing. Yeah, so let's do an example. So this example, it's actually taken from Motorola website. In 2013, they introduced a new mobile phone, and they decided to sell it on Cyber Monday with a huge discount, and people started buying basically, and the website crashed. So what was the problem? So the problem was that the Motorola delays selling of its phones, new mobile phones, on Cyber Monday because due to their website crash. So how should we start? So that's the problem. So the problem with sales, why we didn't manage to sell the X number of this new mobile phones. Okay, why? Why were sales of our amazing new Moto X so slow? Okay, let's think. Because demand was much higher than we anticipated, right? Why was high demand for our new product a problem? Because potential customers couldn't process orders through their website. Yeah, so that's the issue with the website. So why couldn't customers place orders on our website? Yeah, good question. Because our front end, okay, because our front end Motomaker customization software couldn't handle the demand, and the traffic spike crashed our site. Yeah, and one of the feature of this phone, it was a customizable design. So everyone went to this customizable section. Okay, so that was a problem with the front end. Why couldn't Motomaker handle the demand? Yeah, good question. Because our performance testing was insufficient. So why was our testing insufficient, and how do we fix the problem? We failed to test for high volume on concurrent orders, and we need to fix this software to be able to handle such demands. So you see, so we start just with very general problem. So what was wrong with our sales? And it wasn't just that the website or front end was bad. So we found the problem that we didn't do this testing. We didn't expect, and we didn't do this performance testing. You can try even to dig more why we failed to test the high volume and find some probably issues in the process. But at this stage, you can say, yeah, we understand that we didn't do this testing. And if you want to dig more, why we didn't do the testing, yeah, you could try to ask more why questions. Okay, there is another example. That's about the code. So when we start working on a new task, we spend a lot of time getting the code into workflow state. Yeah, that's a problem. Why? Because the build is often broken in source control. Yeah, good. Why? Because people check in code without running their tests. Yeah. Why don't they run tests before checking? Yeah, very good question. Because sometimes the tests take longer to run than people have available. Yep, problem. Why do the tests take so long? Because tests spend a lot of time in database setup and tear down. Good. Why? Because our design makes it difficult to test business logic without touching the databases. So you see, you started with something very general that they spend a lot of time just getting code in working state, but the issue was with the design implementation. Not even with test, why they can't do this test, but with the design implementation. And it's a very good example. So it's something which you could do in your daily life as well. So which solution? So what the solution is? The design is improvement. Yeah, that's easy to do. So the design is improvement is probably too general statement. So you can add something because you know your product, so you can directly address the problem. So you can add something like separate databases and something like this. But in general, you see what was the problem, what was the statement, and how we get the answer. Right, so let's see how we apply 5 whys. So which problems we have with 5 whys. So the main thing, and I mentioned it today, is to understand where to stop asking whys, 5 whys, right? Whys, why? So experts, just practitioners, very experienced practitioners, they usually say that you have reached the true root cause when the answer to your question, to your why question, is a process, policy, or person. If it's something else, that's probably not a root cause. And actually what I mentioned earlier, that you need to consider if you can implement the root cause within your organization. So if you can't implement within your organization, that's not a root cause for you. So also important understand, are the questions and answers significant enough to consider the project scope? Yeah, again, how relevant are the questions and answers we get to the regional issue? And did you find a root cause that helps you control or avoid the situation? That would be said. So if it happens again, if the issue pops up again, so it means that wasn't a root cause. So I would say, so some people say that it's kind of art asking 5 whys, and it could be a problem. So the different people, they could ask different questions, and that's fine. So your organization could give you framework for asking this 5 whys. And actually it was one of the problems when in Toyota, they didn't know how to ask why. But you will see, it's just a habit, or you can just have a framework, you can ask people, you just can have like brainstorming sessions. And again, just let's see what you got at the end. So you're not blaming people, so it's not a person. If it's something about the process policy, mainly, so that's probably a root cause. That's I would say that's advanced 5 whys technique. So in the examples we just saw, we had just one answer, right? So we went just one track, but you could have more. And so typically you have more than one answer. So you have this like kind of different routes. So you have more errors to follow, more tracks to follow. And it's very important not to skip different levels. And it's important not to leave these loose ends. So if you have 2 answers on our question, okay, you can investigate all of them, but then to find the most probable root cause. So that's a more complicated one, but if you're not sure that you have just one answer, you could do this advanced method. Okay. Right. So 5 whys, as I said, it's a very simple technique. You can use it basically for any kind of question. So for instance, in my company, project managers, product managers just used to understand what's the real cause of some clients, I don't know, desires, I would say. So quite often they come and ask, I want this feature, but why you want this feature? Why? And then after 5 whys, you have a clear vision that they have something else. They want something else, which you could implement differently, not just introducing the feature. And it's a very powerful tool for project and product management as well. And as I said, you can ask basically wives for any kind of questions and events, problems. Okay, so that was a simple technique. So let's see another one, which is Pareto analysis, Pareto principle, or Pareto charts. I'm pretty sure you've heard about the Pareto principle. So it's kind of universal pattern which exists everywhere. So the Italian economist Pareto, even in the 19th century, he found that 80% of the wealth in Italy was held by 20% of the population. And then it was actually found in almost any industry, any kind of part of your life. So for instance, 80% of work of an organization is done by 20% of people. Or 80% of failures results are caused by 20% of potential reasons. Or any like, I don't know, 80% of bad parts come from 20% of suppliers. So how actually can we use it? I will show when we can use it. So if you know that this 20-80% principle works, so for instance, when you have a selection of defects or test cases, and you don't have time to try everything, right? To test everything, you can just select 20% of them, and based on this 20%, you should do your work. So the 20% of defects, for instance, they can be considered as a representative of all, and for test cases as well. So main thing when we can use Pareto charts. So if you're analyzing data about potential root causes problems in the process or the frequency problems, so when you're dealing with many different problems and causes, but you want to focus on something significant, something important, so you need to select, to do the selection. So the Pareto charts are only useful for certain types of data. So that's another complex, probably the main thing about the Pareto principle. So you should have the certain types of data. Yeah, and when you have these charts, it's quite easily to convey information to others about your data. And it's probably a general statement. So with any kind of root cause analysis technique, you can easily convey information to others. You can show why, for instance, when you have one of the decisions, you can give them the root cause of this decision. You can justify why you did like this. And that's very good benefit of doing root cause analysis. So that's the process of building Pareto charts or doing analysis. So it's kind of, so this process is tailored to Pareto charts, but it's general as well. So the statement, we understand that we need to know the clear problem. Then we need to collect our data. So that's the most important step in this analysis. So we need to choose what we are going to count and for how long. It's not necessarily that you need to count it. You might already have it. So let's say if you have all your defects recorded in your backtracking system, you just need to understand, to categorize them, to understand which factor you would use for categorization. If you don't have it, you just, let's say, you know there's something happening and you need to count it, you probably will need to spend some time. Then you tally your data just to present a nice way. Then reorder your data, just start with the highest number of the occurrence first, then build the chart, add the cumulative line, and analyze the chart. Okay, let's do an example. So again, because you need to build Pareto charts, right? So you need to build a chart, you need to use some tables. As I mentioned, there are tools. There are lots of tools. I just use Excel. So that's up to you. If you have this tool, if you know how to do it, it's very easy to conduct. There are lots of tools. Okay, so what's the problem? What is the problem? So this is example from machinery. So the assembly line stops. We know that it stops, and we would like to understand why it happens. It happens often. Why it stops often? So in this case, we will need to count how often it case. So we need to make a list of the common causes and count them. So this is an important step. So when we need to create this list of causes. So we need to do it, in this case, we need to do it in advance. But as I said, if you have this data, you just need to use one of the categorization frameworks. So for instance, in our problem, so the causes could be missing parts, missing tools, wrong parts, block line, maintenance issues, or other. So other, it's something which we didn't think about, but it could happen. Okay, then we will need to do observations. In this case, because we know that something is happening, but we don't know what. So we'll need to do this observation, we will need to do this investigation and count basically how many times these causes, which we just defined, we observe. Once we have it, we just reorder the data. Yeah, this is what we have. So that's the causes, the problems, then the occurrence, number of times when it happened in the period of time which we predefined. Then this cumulative count. So basically cumulative count. So you see, we just sum up like 75 plus 8, 83, 89, 93, 95. So why do we need this cumulative line or cumulative count? Because it will show us where this 80%, okay, 20% of causes live. So let's see how it's on data. Yeah, that's our chart. So basically, we just draw how many we have? 5. We have 5 causes, and we have 95 in total events. Okay, so this cumulative count, which I just mentioned, is this cumulative line. Yeah, I added another column, the orange one. So the blue one is just occurrence, so how many times it happened, and the orange one is this cumulative count. So why do we need the, and then cumulative line. So why do we need this cumulative line? So basically, so the purpose of the cumulative line is to show how aggressively each new item adds to the overall number of errors. So in this case, this you can see 0.79, it means 79% problems happened because of the missing or wrong parts. And that's it. So you see that the blocked line, that's you just 8%, that's the missing tool, another 7%. So, but the main part, the main contribution is done by wrong or missing parts category. So, so now you need to do the conclusion, right? You need to draw the conclusion. So what we can see from the chart. So as we mentioned, that the missing wrong parts category is the biggest contributor to our problem. So we can repeat our observation, and we can break probably this missing wrong parts category to something else, and just to find another causes, to find another reasons. So what does it give us? So it gives us opportunity to focus on the most important things first. So we have lots of problems, but again, we don't have enough time. So we will invest our time in investigating missing and wrong parts. And then if we have time for something else, we can do other categories. So it's very important when you do the selection, and it's like with prioritization. Let's say when you need to prioritize what kind of test you want to run or which defects you have, which areas you would like to test, you could use this Pareto analysis. But the main problem, the main issue you could have, that's selecting the correct factors, the correct categories. That's what I just said. So the main problem is just to find these groups of defects, or to find the groups of categories which could be representative. So if we're talking about the defects, quite often organizations, they have their categorizations. They have tools, they have this checklists. So these categories, these groups, are predefined. So let's say if you're talking about the defects, it could be something defined by priority, severity, I don't know, areas, different areas, different kind of mistakes as well. So you can have these categories predefined. And it could be actually applied to different areas as well. So let's say if we're talking about project management, for instance, so product management, and you would like to understand engagement or your customer satisfaction, you could conduct some surveys with some predefined questions. And these predefined questions, they could give you basically this starting point, these factors. But this 80-20% rule, it's just a rule of thumb, right? 80-20% is just a rule of thumb. It's not just 80%. You just need to find exactly 80%. No, it could be 70, it could be 75, it could be 90. It's just a rule of thumb. So basically, you should see this kind of pattern. When you have it, you just select, okay, this amount of issues could be representative. We could select them first. Yeah, and I just mentioned that if you have these categories, it could help you to speed up the process. That's the most complicated part about the Pareto analysis. If you've done it correctly, everything else should be easy. Just use it too. Yeah, that's one of the example. I took it from the standard IE 1044 investigation classification schema. So that's for software testing, which categories you can have. So if you go, for instance, to this standard, you can find some other categories. And in books regarding about the test process improvement, they also have the different categories. So basically, if you want to start this framework, if you want to have the starting point, you could just find extenders and just try to use them. So here we have something about the impact, frequency, if it happens on production or not, method of detection, some attributes, domain-specific defects, standards, rejected development. So it's basically lots of things you can use. But it's very important to find this kind of right category, right factors, I would say. Because in some examples, you probably wouldn't see this 80-20% rule, this principle. So if you don't see it, just please try different factors, try different categories. So it means on these factors, it doesn't work as you want. As I mentioned, so it works on the quantitative data, right? So with the qualitative data, you still need to find some numbers. So you need to count somehow. In this case, you can just count number of defects, depending on one of these categories. But again, it's important thing, and I like it to use just for this selection purpose. When select test cases, for instance, it's very powerful tool. Okay, so we just discussed two simple techniques. So we said that probably the best tasks, not the best tasks. Okay, so probably we should use these techniques for simple or kind of not very complex problems. Because with a Pareto chart, it looks like a formal technique, but it's still vague in terms of defining these factors. From the very beginning, this data. So if you would like to have something more formal, and the process could be done in a more formal way, we could do, for instance, a fishbone diagram or Ishikawa diagram, herringbone diagram, of course, an effect diagram. So you can find different names, but basically it's the same name. So it was introduced in 1960s. The guy Ishikawa, I believe he's Japanese as well, and he worked in shipbuilding industry, and they needed to do formal root cause analysis. So why do we call it fishbone diagram? So basically because the shape of the resulting diagram looks like a fishbone. I will show later some examples. So this diagram is predicted on the idea that multiple factors can lead to the failure. And that's an important thing. So the cost diagram, it's a graphical representation, right, of interrelation of various possible root causes. So if in Pareto analysis, again, Pareto analysis, it could be multiple causes, but in firebites, it's most of the cases we're trying to find one cause. Here in the fishbone diagram, we need to consider all causes and spend time just on all causes. So this method is particularly useful when you're trying to solve complicated problems, because you see it's very formal. Wow, okay, that's one of the examples. So basically, why it looks like a fishbone. So when we have a problem, we just write it in oval, I don't know, in a circle or in a rectangle. So it reminds us of the fish head. So then the backbone provides the main path to the defect. And then we have different possible causes. They should be grouped in the categories. And then we start finding fish bones, like small finer bones. And these finer bones actually are our root causes. That's what we are looking for. And you see this different group of causes. So that's an interesting thing, how to define this group of causes. Again, it's very important, and actually it eases our investigation when we have this kind of framework, when we have these categories. I will show you some examples. I will show some categories later. So let's go quickly through the process. Again, what we mentioned, that we need to have a group. We need to have a working group. And because it's very formal technique, in this case, it's better to have this working group, right? So we could use the form of workshops, brainstorming sessions, or reviews. It's not necessarily to have such as brainstorming session. It could have different approaches. Then we need to decide which kind of diagram we would like to use. They're different, they differ a bit. And who should be involved? Who should be involved? We discussed earlier that people who were involved in the problem, it could be someone from management or people who could contribute, who knows the area as well, who could also contribute. Then we need to set up the diagram itself. Again, identify the problem, who is involved, what the problem is, when it occurs, and then we just build it like this, just like a head of fish. And again, it should be, the problem should be stated very clearly. That's the important thing. Well, the second, which you just mentioned, so we need these major factors involved. So that's probably one of the complicated things here, is to define these factors. But as I said, the standard categories can be used to group this information. In this example, so this example from the Ishikawa website, so they define 6 categories. For instance, equipment, so it's hardware and networks. management, who involved, measurements, metrics, methods, for instance, test strategy or any kind of strategies, people, who stakeholders, skills, communication, environment, working relationship, and cultural issues. So that's one of the frameworks. So that's one of the set of categories. You could have different one in your organization. If you don't have it, you could use one of the standard categorizations. So, for instance, here we have another two categorization set of categories which you could use in, for instance, in software testing or software development. So we have an example here. The problem is low developer velocity. Why does it happen? Here we have four categories of factors, some methods. So methods, it could include software development lifecycle, QR process, any methodology like Agile, Waterfall, and problems related to them. Code, so the source code, artifacts, packages, libraries, frameworks, whatever you use. People, team members, co-workers, stakeholders, skills, systems, so the system under development, releases, deployments, testing. So that's the categories we use in this example. So another generic one, it's materials, vendors, people, systems. So as I said, you could find different, you could have different ones. Something, but I would say if it's software testing, software development, this example kind of gives you what you need. This is basic starting points. So let's say we have method. So what was the problem? And then you start looking for finer bones, these questions, right? The causes. That's not a root cause yet, but that's something which could lead you to root cause. So for instance, process is not clear. Yeah. Too many meetings. Yeah. Methodology is not agile. Maybe. Code, too much technical debt. Right. Complexity is high. Tests are hard to write. There are no tests. Yeah. That I believe, I don't know, I probably could use this diagram just straight away to my company problems. People, team is not working well together, needs more training, project is boring. And systems deployment take too long, dev databases is down, development servers are down. So again, it's not about blaming people. So we're talking about the processes, right? Different processes, what's going on. So the next step will be to refine these causes, trying to find some other issues, which could be some other causes, which could be potentially root causes. So identifying possible causes. That's well difficult probably part. So we could have brainstorming sessions. Once we have some causes defined, we can add more information, some probability, because some of the causes could be more probable, some less. So if you know this probability, or you could at least discuss this probability, this information could be very useful. So if the cause is large or complex, you can break it. And yeah, you should break big statements. That's for sure. You can try to link different parts of information, because even if they're under different categories, they could be linked. So you could have just one cause. And checklist, again, if you have checklist of common root causes, that could be very useful. In testing, in software development, again, in different industries, you could have this checklist defined, predefined. In your organization, you can just try to use standard ones. And for instance, here I just took from the Improving the Test Process book. So that's probably top 5. I will show later some other classifications in software testing, but that's 5 most important which defined in this book. So the test environment used has not been adequately updated. Yep. Failure to update test environments again. Results from dynamic tests were reported as false, some false positives. Types of structural coverage required and misunderstood by testers. Developers supporting the model test have insufficient skills. Yeah, so that's 5 things, but you have definitely more. That's kind of 5 top. And I would encourage to use, at least from a starting point, checklists. And if you could spend time just defining them before you're doing these root causes, that would be amazing. But again, you can find something internet and book standards. So yeah, analyze your diagram. So once you have this fishbone diagram, you should go from the top down, work from top down through the hierarchy of causes and trace different paths. So depending on complexity, importance of the problem, we then need to investigate the most likely causes further. And at this stage, it could involve setting up new investigations, carrying surveys, and something else. So when you find path, this likely path, and when you find this kind of route, you might need to spend more time just doing another level of investigation, not necessarily in this working group, but someone external as well. For instance, carrying out surveys that could be done external, or to do some kind of probabilistic analysis as well. But quite often when you assign probability, you know roughly what you do, because the people who are involved in the process, they know this area. They know what could be more plausible or not. But at this point, it might require another level of investigation, maybe even new diagrams or even new techniques. Once you're happy probably with your root causes, with your analysis, you should draw in conclusions. So we should first decide whether the conclusions can be drawn or not. Maybe we need more information, maybe we ran out of time, maybe the problem is too complex. So if you think that the work group is confident that the right root causes are identified, we just need to double check a few questions. So again, was this one-off event? Can we identify any common causes? That's an important thing as well. Check needs to be made to see if some similar causes have been identified in the past. Yeah, once you conduct this analysis, you quite often can spot some trends. And as well, as we said before, the root cause analysis gives you opportunity to find these patterns, to find these trends. So once you've done root cause analysis for, let's say, one problem, for certainly you can link it to other problems, to other issues you had in the past, and you don't need to carry your analysis for these issues. So it's very important to link these issues. So if it's just one-off, that's another thing which you mentioned. If it's just one-off, so maybe it wasn't so important. Maybe we should do something else instead of just spending all this time to run this diagram, to run this process. So again, if you do it quite regularly, you can spot, you can see very easily if it's the problem you should consider, if this is root cause. So if you do it regularly, it's easier to understand what to do with these results. So yeah, once you have these conclusions, you just need to do other recommendations, right? So which recommendations would be better to address the issues you found? Okay, so let's see another example. So the problem we have, so a manager is having problems with an uncooperative branch office. So the manager can't actually work with his office, right? So he had different branches in one of the offices. So the first step will be identify the problem. So the problem is uncooperative branch office. Well, So we said that we need to start and we need to draw this fish head, right? So it could be either on the left-hand side or right-hand side. It doesn't matter how to start it writing. So if you use a tool, it should be probably predefined. But in this case, it's just on the left-hand side. So the problem is uncorporative branch office. Well, main factors that the categories, you remember the categories we had. So in this case, we have 5: task, people, site, equipment, control. Yep. So site, task, people, control, equipment, it's very high level factors, very high level categories. So in this area, we decide to go to this framework. Well, the next step to identify possible causes. And that will be the difficult part. Yeah. That's an example I took from a book. So there are lots of different causes, but let's say to dig to the main one. So let's say we spent some time just trying to find these causes. You see that it could take a lot of time. So just save time. So I'm using this picture. So the site, we said site, one category site. So site, it's about where our office is located, if the building is fine, some crime, some depressing one. Another tasks. So tasks, so which tasks we have in this office. So what they're doing, which result they have, sales, what went good. So how do they do their tasks? People. So we can define even people. I don't really like this people category. So it's better, well, in this example, there are like four managers in this office. So in this example, it's probably fine to use people names. And some characteristics, people characteristics, but as I said, I would prefer to use something like skills, maybe skills, so something, if you want to use the people category, that's very specific one. But in this example, that's important category as well. Equipment, so what kind of equipment they have, if it's modern, if they have software, hardware they need, and control, which is important one. So for instance, one of the managers, Jane, quite often missing meetings, calls, they have some urgent job to do, some contracts, they don't understand their work, some changes to the strategies they don't understand. So the causes, they're very specific, but because the manager who's conducting this analysis knows what to expect, knows this office, they selected these categories and then find these causes. So if we didn't do this approach, if we didn't use this diagram, we just might have assumed that people just difficult. They just don't want to cooperate with you. But again, we're not blaming people, right? We're blaming processes. So the true cause, it's communication, right? It's communication. So, and the people, they're not understanding the strategy, they're not understanding, because they're not understanding strategy. So, but basically the manager went the route, this right-hand side, where's the control. So does she understand strategy or sales? So that was the main root cause. Because the others, there's some causes, but the main root cause in the control section. So the decision was to arrange a meeting with the branch manager, Jane, and to trying to fully describe the strategy, to talk through the problems. So once you came up with all these causes, with all these ideas, because you see they're quite, I don't know, generic, they're quite specific, right? They're quite specific, and you can say that they're general. So like, I don't know, crime. Yeah, but it could be the reason. Some, I don't know, modern equipment. Again, they're quite general, but if you then go down, you can find something specific like They don't understand the strategy. And once you have it, and again, it's about the process, right? So you know that that's probably the root cause. And you can try to address this root cause. Well, that was a long one. I would like to say again that it's very formal technique, and there are tools which could be used. Basically, in these tools, you just type your factors, you type your categories, you type your causes, you add just like a factor like probability or something like this, and then it draws you this diagram, and then you can pick up different roots and analyze like root by root. So when you have this fishbone diagram, you can just pick up all different tracks, all different roots, and try to see how they're plausible or not. So we have two more. So this technique, it's not probably a kind of root cause analysis technique. It's failure mode and effects analysis. So this technique, it's technique from risk-based methods, and it's proactive approach to root cause analysis, which should prevent potential failures. It's a very formal, it's a very heavy. I will show, I will talk probably quickly about this technique, and I will show you example later. But it's a risk-based technique. And we had the workshop, I think it was one of the first workshops which Anton Mujailo went through, risk-based techniques. I'm pretty sure he spoke about the FME analysis. So it's very formal. You have tools, you need these workshops, you need the sessions, and you need to assign all scores. So this very structured technique. This empirical approach to understand the potential impact of something which could go wrong in the process. So it's based on the failure modes. So basically, failure mode is anything which could go wrong. Again, it's kind of factors, right, which we saw in root cause analysis. So for each failure mode should be assigned 3 factors: severity, occurrence, and detection. So severity represents how bad the impact of failure would be, ranging from 1 to 10 roughly. So 1 when it's not really important, and 10 when it's really important, when it could have big impact. Occurrence represents how often the failure occurs, ranging from extremely unlikely to something which is very likely. And detection represents how likely you to catch the failure. Again, from 1 to 10. And then these scores, they combine to produce a risk priority number. So basically you multiply all these numbers and you got your risk priority number. So what to do with this number? So this technique tries to predict future failures and defects based on analyzing past data. So actually, when you're trying to predict some failures, some causes, you could use results from root cause analysis. So it's spotting problems before the solutions is implemented. I would say these risk-based techniques, these proactive approaches, and root cause analysis techniques, they're very interconnected. So the first one, they just preventing, they're proactive, and root cause analysis trying to find. But in some cases, you could actually use these techniques just interchangeably. And in this failure mode analysis, you could use information based from what you got from root cause analysis you conducted before. And that's very good. You could actually just probably save some time for doing root cause analysis if you do this technique right. Okay. Okay, so let's see what we have as an example. So the process is just driving interval, but it's very generic one, right? So it's the statement is general, and we mentioned that we need something which is more specific, and the same here, the same rules-based techniques. So we can break into some sub-processes like driving through town, merging on highway, breaking out of the driveway, navigating traffic jams, parking, and so on. So let's say we have these 5 sub-processes. Then we need to define what's failure modes. Basically, so this is kind of categories, our problems, right? And then we need to define what could go wrong. So in this example, we will be discussing breaking out of a driveway. So we have 4 possible failure modes: hitting another car, yeah; running over a toy, maybe; hitting a person; being hit by another car. So that this failure modes is what could go wrong. And this categories, these failure modes, it's again, they could be based on some frameworks, on some past data. Then we need to populate these tables. So they call it like scorecards, and you could do it for for each sub-process. So let's say we have failure, hitting another car. Yes. So which effect we could have? Vehicle damage, potential injury to a person. Then the severity is 9, of course, maybe 10 even. Okay, it's not death, so 9. Potential cause, distracting driving, good. Occurrence, 3. Yeah, 3 may be all right. Controls, so adjusted rear view mirrors, 6. Yeah, maybe 6. And in total, when we multiply 9, 3, and 6, we got 162. So why do we need this number? So this number gives you idea, so which problems you should address first. What should you mitigate first? So once we have results, right, we need to implement, once we have the scores, we need to think about the correction. So the main idea of this method, of this technique, is to reduce either severity or occurrence or detection. With severity, not much we can do, sorry, hitting another car, unfortunately not. So we can think about occurrence, yes, and reduce likelihood that you will hit another car. Yep, important. And then based on this kind of this failure mode analysis, it's based, failure mode and effects analysis is based on two things. So the first one, it's defining all these causes, numbers, and the second one, which is important as well, corrections. So the corrections, it looks like the same. So it looks like this. So we need to think what we can do based on the scores. So how we can reduce these numbers. So what actions can we take to reduce the severity of hitting the car? Yeah, we said that. What can you do about occurrence? Yep. Okay, so what we actually came up with? Just install a backup camera. Amazing. So you need to assign a responsible person who will be doing it. Again, it's very formal. You can have different types. So you can probably do it in a more informal way, but you should know that it's very formal technique. Then actions taken, backup camera installed. In this case, so let's see numbers. So severity 9, occurrence was 3, right? Now it's 1. And detection was 6, now it's 3. So we managed to reduce it to 27, the total number. It used to be like 162, now it's 27. So before we go to the last one, fault tree analysis, so the actual fault tree analysis, it's kind of the same type of technique. So it could be preventive, again. It could be used as well in as a risk-based technique. So it could be could try to find potential causes, could be defect prevention tool, or it could investigate the failure, trying to find the root cause. So it could be used like preventive or just like investigating tool as well. And it's kind of, you know, different sides of one coin. This risk-based techniques and root cause analysis. And I will probably talk about this later, but anyway, so the root cause analysis, it's a part of the whole test improvement, not only test improvement process. So quite often, especially in large organizations, it's just a part of this process. It's never conducted as just like this. When you use it just like 5 whys, yeah, you can use it, absolutely. You can use it in retros, in any kind of, but if it's really part of a big process, a big organization, is just one of the methods, one of the things which could improve your process. And risk-based techniques as well, it's another part of this improvement process, and root cause analysis. That's kind of two things in one methodology, I would say. So, okay, so the last technique is fault tree analysis, FTA. So this method for identifying root causes and uses Boolean logic to figure out the causes of failures. It was developed in Bell Laboratory for Continental Ballistic Missile Launch Control System in the US. So you can see that it's formal as well. So just would like to highlight that it's formal technique as well. So when should you use it? So FTA is the most effective for more complex functions, but it could be used when even it's applied for some small problems. And I will show you a few examples, simple examples, but it could be very useful for complex functions. And kind of the tree analysis structure, I think, especially in software testing, software development, is kind of nature for us. So FT utilizes the potential of teamwork to bring in a variety of ideas and broaden thinking. Yeah, that's what we do with almost all techniques. And also deciding the scope from the beginning is essential. I think it's essential for every technique, but in this particular, it's important. So it's based on Boolean logic, as we said, and there are two main logic gates, and or. So and we use when events should happen simultaneously, or when either of the events may lead to defect. That's basically what you need to know. And again, it could be done in a formal way, it could be done in a formal way, depending. So in the example I would like to show now, it's done more, I would say, informal way, but it could be done in more formal. So the problem we have here, computer not starting. That's a bad thing, but it happens quite often. So the problems, the statement, computer not starting, right? The next level, it's kind of which causes could be no power or booting problem. So in this case, we use or, right? Then let's say the level no power, we have another. So the power socket faulty, power cord faulty, that's or power outage, UPS battery down, that's and. So you see the different signs. So kind of, I don't know, triangle one, it's for or, and this, I don't know, we call it 5. And another one anyway, that's for and. And for booting problem, we have 3 ors, motherboard failed, OS failed, hard drive failed. In this example, we have just 3 levels, but you can drill down, let's say, to power socket fault if you want, or hard drive failed. But quite often it's not necessarily to drill down very deeply. For instance, UPS battery down. No, for computer not starting, that's not really important. Why is the UPS battery down? It's important it's down, but not why is it down. It's more important probably why hard drive failed, or why OS failed, or motherboard failed. That's more important. Or why power socket failed, maybe more important. So yeah, as we just mentioned, ors or ands. Yep. And we can draw more levels. That's just example, just very simple example, just to see when we use or and. So probably in this case, we're more interesting by motherboard. This right hand side root, that's probably more important for us, and it probably that's more probable. Okay. So yeah, trace UPS. Yeah, as I said, it could be either very formal or informal too. So the example we just saw, it's quite informal. You just use notations, but you can just say or and up to you. Just use any kind of notations you have. But it could be done in a very formal way, using different symbols, gate symbols, as we mentioned, and or events, basic events, conditional events, whatever. And it could take more time to build it, but basically the same. And again, you should use tools to build it, just to draw all the things. So, okay, let's see what we have on this example. So the problem is you flip a switch to turn on a light, but the light does not turn on. That's a problem. So the default condition is no light in the room. Again, it should be stated clearly. Then we have three options. And so in this case, you have more than two, right? So in the previous example, we have two, it could be three, it could have more. They could be, could lead to or than to and. So these schemas, they could be more complicated, way more complicated. That's just a simple examples. So what we see, all bulbs burned, switch failed, no voltage. Yep, maybe one of these. So if all bulbs burned, here we have and, because we have one lamp and we have two lamps. And if we go another route, so no voltage input. So in the switch fault, actually that's a basic event. We don't need to add anything to this. And voltage, or we could. No voltage in input, so we have two ORs, no V network, or no voltage network, or no fuse point. And then you can drill down again. That's just a very high level thing. I really like this approach. I don't know, for me, it's very natural just to see which causes, how they could be interconnected. So when you collect the data, you're trying to see the event. You're trying to see the sequence of events, not just one event. You're trying to see the sequence of events, and when it's presented like using a fault tree diagram, that's very natural. And this or ands that could give you quite quickly, I would say. So I mentioned on one of the slides, I mentioned two other techniques, but they formal and they specific to some kind of problems and industries. So I would like to stop on this 5, if you don't mind. If you want to read more, so yeah, there are books on how to conduct different kind of techniques. So lots of different books, and especially when you work in kind of industries, I don't know, engineering, machinery, healthcare, aviation, they have all their handbooks, how to conduct cost analysis, how to do these techniques in the right way. Right, and the last slide, yeah, not least, but last slide. So classification. So again, you can find different root causes. I showed you before. So when you can kind of have this framework, these tables, potential root cause classifications, there is a chart that was so the investigation was conducted. I don't remember which organization, but anyway, so these numbers from the investigation conducted an organization for some period of time, and they found the main root causes they have. So you see the wrong requirements, and we know if you have wrong requirements, problems with requirements, that's most frequent problem, and it could lead to big problems later on. So if it's not fixed in the early stage, it could lead to some wasting of time, money, resources later on. Interface error, missing requirements, incorrect error handling, logic error, configuration exceptions, standard compliance, some invalid data. So you can see unclear requirements, but there are how many? 3, right? Unclear requirements, missing requirements, and wrong requirements. So for software development, for software testing, these kind of things, they happen quite often. And I believe you have something like this. So if you do analysis, if you do some investigation, you should see pretty much the same numbers. But again, it depends on organization. So you could have some specific to your work, to your organization things. So yeah, that was the last slide. I just would like to sum up the main things. So the root cause analysis, this technique could be used to identify any kind of, or yes, any kind of problems, events, not necessarily just defects. As I just mentioned, in project management, it could be done lightweight. Then there are 2 main problems: to start, to collect this data, to figure out these factors, these high-level factors, and then to decide when to stop, or to be sure that you found the right root cause. That's kind of the main things, and the general, regardless the technique you use. So I would highlight again. So if you find root cause and you can't fix it, even if you conduct it during your retrospective, and it's something which you can't do within the team or within the organization, that's not the root cause. You need to find something related to either processes, policies, okay, people, I would say training. I don't want to talk about people, but most often it's processes and policies, I would say. So if you find something like this, that's probably your root cause. And if you implement corrections, if you implement recommendations, and it happens again, so you know that it wasn't root cause. And the good practice is to try to combine these root causes, try to combine kind of different, I wouldn't say just do root cause analysis for a few problems in one time, no, but you would see the patterns, you would spot the patterns. So once you start doing it regularly, you would find some trends, I would say. All right, so actually it took us less than 2 hours, and yeah, we have even 20 minutes for questions. So I hope it was useful. Thank you for listening. So if you would like to know more, you can reach me out. I can probably send you some books if you want, or some more information, or just probably give more examples. In my practice here, we're a small company, so we don't do the formal things. We do it in lightweight, and so we've done it for some period of time, and then we benefit as well. Okay, so if questions, okay, thank you. So yeah, so the 5 whys fishbone diagram, they're quite common. I would suggest to try Pareto analysis and fault tree analysis. I really like fault tree analysis. It's very cool. Yeah, and again, if it's a formality level, it's very much depends on which technique you would like to use. It very much depends on your organization, on your time, on your resources. What you would like to introduce in your company, can you share the books? If you want now, just give me probably a second. I will type. Just let me. If I just find something, give me a second. I will. Yeah. If you have questions, I will just find. Yeah. Just type here. So basically, the root cause analysis, you can read about the root cause analysis, some techniques in any kind of test improvement processes. So the one which I mentioned a few times, just let me find. Yeah, if I go back, sorry, it will be faster. So sorry, definition. Yeah, so the one. It's Rex Black Advanced Software Test. So Advanced Software Testing. That's not one. There's recent another one on quality management. I will type it in chat. So the quality management. But you can find something new on quality management tools, techniques, and techniques. Let me see. Then there is a handbook on root cause. If you just Google it, you will find it. I think it's the most popular one in the book. That's the name. And then basically any book about the test improvement process. The one I used, test improvement process. Graham Bach. I don't remember the exact one, but something like this. So yeah, the root cause analysis is just a part of test improvement process. So any book you can find on test improvement process, you should spot it. So all these handbooks on root cause analysis, the one which I just typed, it's very industry specific. This one particularly, I think it's from engineering or machinery. So there are lots of books. But if you want something which is specific to software development or to software testing, it's better to search something for test improvement process. I don't remember, can see the book's names. So the quality management tool and techniques. If you want, you can just send me a message to LinkedIn and I will probably give. So this quality management, anything on quality management, so quality management tool and techniques, handbook, root cause analysis, and test improvement process, Graham Bach. This one I remember. Then if you want to read something about implementing root cause analysis in Agile, there is as well. Oh, that's a good point. Not success of Agile. There's a good one as well. Oh, it's a good question. Let's see if I can find it. Anyway, so you can try something Agile as well. It won't be a whole book. It will be just probably a chapter. So in this test improvement process book, it's just a big chapter. In the Agile one, it's a chapter. So if you find something on Agile, how to do Agile better, something like this, root cause analysis could be mentioned as well as a technique to run retrospectives as well. And yeah, lots of books, lots of articles, standards as well. But that's what I like, what I read. Okay. Any other questions? So yeah, techniques, if you want to read more about techniques, for instance, in this book I just mentioned, Test Improvement Process by Graham Bach, they use Pareto analysis and fishbone diagram. So if you want to read more about how to conduct fishbone diagram analysis, you can do it. So how can you decide which technique to be used? Well, yeah, good question, very good question. Let me find the slide and I will talk again. Yeah. So the first, you need to decide the reason why we want to conduct root cause analysis, right? Before you start selecting a technique, you need to decide if you need it or not. Then the next thing is to understand if you have something in your organization. So, because in different areas, in different departments, you might already have root cause analysis implemented. So it means they have kind of this process they introduced, and they could have some categorization frameworks, anything. So if it's done in your organization by different department, for instance, you could start with these techniques, because some organizations, they might prefer this technique or that technique because it's industry related, organization related. So the first thing, if you already have it, you can just try to use this technique. So if you don't have it, you need to see in which industry or which kind of product you're doing. Because okay, if you're doing outsource, you can have different products, right? If it's something which is healthcare related, something which is critical, right? Critical mission systems, critical, you should go for more formal techniques. If it's something which shouldn't lead to critical failures or big failure impacts, you could start with lightweight techniques. I would suggest start with a lightweight technique, and just to see if it does the job or not. Because from what I was told, people even in large organizations, they don't want to do formal techniques. They don't want to spend time, even in very large organizations, if it's not a part of a policy, and if it's not a critical mission kind of product, they tend to do lighter weight techniques. 5 Ives, Pareto analysis, maybe fault tree analysis, even fishbone diagrams, or in lighter way, but they don't want to spend these months to conduct root cause analysis. So yeah, so the level of formality, it could also be based on the time, resources you have. Because even if you want to do it by yourself, it's still as a tester, or as a product manager, it's still your time. So you need to think how much time you want to invest in this process. And if it's just, if it's done within the group, so it's resources. So again, your organization kind of past experience, then your industry, then your resources, your knowledge as well. But quite often big companies, they invite someone external to help to conduct the sessions, to help to run the things. If you want to do it by yourself, if you have time, start with something simple, just categorizations. Yeah, I hope I answer your question. Okay, so another question. Could you please be more specific how to define which defects the best to be considered for root cause analysis if we have hundreds of them? Well, hundreds of thousands. Yeah. So you have a few probably ways. So you can start again from something critical. So let's say if your defects, they have, I don't know, priority severity number then higher than something, you could start with this group. So it's better probably to categorize them, right? To have this different category, like most severe defects, or the area, something at least, or I don't know, based on area or something, to have these different categories. Because if you have hundreds, right? Like I see your problem. You need to have kind of clusters, right? You have this kind of clusters of defects, if you can do it. So if you know the area, brilliant. If you know, if you assign severity or priority score, that could be the way to go. So as I mentioned, for instance, in Pareto analysis, you can start with Pareto analysis and take just 20% of defects, for instance, not to take everything, and to start with the most important. Yeah. So you need to define in your team, so what's probably the most important for you, because you need to start with something which is most important. But I would suggest to classify somehow, if you have this classification, defect classification, I don't know, to classify them somehow, to have this kind of clusters, because quite often they have the same roots. Ideally, if you can do this educated guess, if you could say, all right, this happens because of the memory leak or because this is this. If you can't do it, that's fine. Just to start with something important to you. And again, try with probably Pareto analysis. Take this 20% and try to break down. And even if you have this 20%, you can do another techniques on this 20%. But we assume that this 20% should represent the whole group. And once you start to conduct root cause analysis regularly, you would see the patterns. You don't need to do it for your hundreds of defects. I'm pretty sure you would start seeing the patterns. And what I showed you on the last slide, right, and during the presentation, the common root causes, so the common problems, you can try kind of, I wouldn't say, yeah, you can try to guess or use something like this, but I would start with something important. Okay, so next question, could you please advise when it's better to conduct the root cause analysis for agile projects? At the end of the sprint, more often, right? In agile, it's time. It's time. So it should be set up something in your organization. I would say do it regularly. Regularly, end of sprint or end of, I don't know, more often than sprint, no. Definitely no more often than once in sprint. I would probably say maybe 1 to 4 sprints, depending how long your sprint lasts. 2 weeks, 1 month, I don't know. And because I would suggest, and I would assume that in Agile, you would like to use lightweight techniques, right? So, because if you like to use more formal, you would definitely need time to find time for this. And it's probably to do it less often, right? So another thing which you could consider, just to find time, again, and it's probably to do the initial root cause analysis for a big chunk of problems, and then start to do it regularly. Even you can do your root cause analysis during your retro meeting, just to add some time to your retro meeting, because you have the whole team involved, right? So you have the whole team, so you can do kind of lightweight, right? Lightweight root cause analysis in retro meeting as well, but just extend it. But no more often, So no more often than sprint, definitely. Agenda slide. Yep, agenda slide. Can I open agenda slide? Yep. Okay. Yeah, there are no more questions. Let me just follow. So yeah, just let me open agenda slide. Let's open agenda slide. So yeah, that's the agenda slide. So as you mentioned, companies invite members from outside to do root cause analysis separately. Who does the job title as a subject matter expert specific to root cause analysis? Okay, good question. So I don't know how it works in Ukraine, but for instance, in United States, in United Kingdom, they have organizations who do test improvement, for instance, or software development, who do this improvement processes. So it could be external, completely external organization who has these experts who can do it. What the title could be? I would be looking something for improvement process, test improvement process. For instance, Anton Muzhailo, who's one of a committed speaker, he's one of these experts. That's not a word. I'm just saying he's kind of this person. So he comes to organizations. It could be what I'm trying to say, that this person could have different titles, but quite often it's what Anton the title has. It will be someone who on quality expert, definitely will be quality expert, quality improvement expert, something like this. And I definitely know that in US there are organizations. I saw these organizations in US. They have these experts. Okay. How show the customer the benefit of customers as well? Oh wow, that's a tricky question. How to show the customer the benefit? If you see the improvement, if some kind of things stops happening, that's the benefit. The benefit, if you're talking about software testing, right? So the benefit is to see less defects which could lead to severe problems. If you stop seeing these kind of things, again, I wouldn't say, right, you shouldn't see any kind of defects. No, you will see them, right? You're all realists. But kind of, you definitely should see improvements. You should see improvements. How do you conduct your job? So what kind of defects you have, complaints, all this kind of stuff. So that's one of the technique to improve your process. So let's think systemic. Let's think just one part of improvement process. So if you see that something improves, less defects, developers do their job faster, more effective, or something like this, that could be metric. But to define a metric, yeah, that's a tricky question. For myself, how to define? I would say that's probably to do a job more efficiently, just to educate people, to training, and when you've done all the things, you should see the better quality. Ideally, at the very end, you should see the job done faster with a better quality when everything is implemented, not necessarily just root cause analysis. But that's a very tricky question. Thank you. I will think about it. I open agenda slide. Okay, so what root cause analysis techniques used in your company? Okay, thank you. So I'm a lead software tester. So I conducted at some point root cause analysis. We don't do it regularly anymore. I spent quite long time just setting this root cause analysis in my company, and we spent some time just doing it. When we finished the big project, we had lots of defects. So you said hundreds of defects, and then we're trying to find the root causes just to find what's going on. And we conducted these brainstorming sessions. From the very beginning, I did this classification. I did this classification of defects classification, and then we discussing basically the chunks, the clusters of defects. So what I used Pareto analysis to select defects. That's the thing. And then we did the lightweight of fishbone diagram. The lightweight. But I tried myself as well fault tree analysis, what I like, but we did lightweight of fishbone. And another thing, our product managers, they do root cause analysis as well, 5 waves. They do it regularly. They do it basically every day, 5 waves. Once they have once they need to justify any decision, any new feature, basically, which we would like to implement, they do root cause analysis. Yeah, every time. Not on bugs, but on any problem, but they do it. Okay, what are the questions? Companies outside to reply. Yep, you see your companies. So yeah, the companies invite members, external. That's a good thing, because the only person I know directly is just Antonio Jalo, so he might know better these titles, but it's someone who is a quality improvement expert. And there are lots of organizations who do these improvements, who conduct root cause analysis directly for organizations. So once organization sees some problems with, I don't know, their cycles, with their times, with their, and I wouldn't say defects or something like this, but if they spot some issues, they could invite someone external to help to improve the process. Maybe to implement automation testing, to conduct root cause analysis. It's a complex problem. Yes, it's a complex problem. Root cause analysis is a part of it. But you can conduct it. You can start doing at least something, just at least something simple by yourself. But it's very time consuming, and you need to spend time just planning it, even when you have these hundreds of bugs, you need to put some framework on the top. You need to put this classification, just to extract everything, just to invite people to do these workshops, to ask your management to give you time and resources to do it. And as I said, people, they tend not to do formal stuff. So you need to consider what types, what techniques you would like to use. Okay, thank you. Yeah, LinkedIn. Yeah. And if you want to connect, if you want, yeah, please do reach me out to LinkedIn. I might know some other answers, some other things. Okay, so if you don't have any other questions, I think it took us 2 hours. Good timing, and I still can speak, so thank you, my voice. Yeah, thank you guys. Yeah, I'm really appreciated your time. There should be video. I hope we recorded this video. We should have recorded the video. So yeah, if you would like just to listen again, to watch the video, you should have it in your car. Thank you, Jack. Thank you. Appreciate it. Okay, guys.
Thanks for your time.
Thank you for your time. Okay, so have a good day, evening. I don't know what time zone you are. Yeah, so if you have any questions, yeah, please to reach me out. Okay, thanks, guys. Let's stop video now. See you guys.